Good morning. I'm just sending you first document, Solutions to Annuities, and the first document for today's class. I'm sending by email. I'm also just waiting for more people to show up. I'm going to check. I gotta check my class list. I think we have a new student. I usually check the class list to make sure there hasn't been any changes. Looks like there's a new student. All right. So, I just sent you a document called Discounting and Inflation. I did it again. Sneezing. I still didn't clean my fan. Dusty. So I also send you the solutions to the annuities exercises. I should have sent them yesterday. No one complained, but you can definitely ask me if I haven't sent something to send it. Let's see. This one. So this is where I want to start today. Have a look at that. See if you can interpret that problem. Kevin, check your email again. I'm using the class list, Kevin. So if you're not in the class list, if you're not registered, I can't send you the emails. I'm not sending you the emails. So make sure that you're registered. I'm not sure why you're not in the list. Yeah, I don't know why you're not in my list. It's so annoying. Something's really wrong right now with our system. Students are having trouble with registration, and my lists are incomplete or not up to date. So I apologize for distressing you. But yeah, if you checked, that's great. Also, the email doesn't work the way I like it to work. I can't find things sometimes. Like, I'm just seeing if where is that email? Did the other students, did you get the email I just sent? Okay, let me send this to Kevin. I just have some students that are not in the class. And I have some students that are supposed to be in the class, and my lists are not up to date. So I will just have to send it to everyone that ever was in this class. So have a look at that. I'm going to give you some time. I'm going to get you started on it, and then we'll work on that over the next hour, maybe hour and a half. And I'm going to send you some additional documents. Yes, that's right, Kevin. All right, so this is the document I sent. And I start talking about nominal discount rate, inflation, real cash flows. So this is the case where there's inflation, and I give you information on real cash flows. What are all these things? What is the relationship between inflation and the discount rate? So here it's called the discount rate. This is our acting interest rate. Okay, this is the prevailing interest rate that we're going to use that applies to this individual. Suppose the nominal discount rate is 8% and the expected inflation, auto installed. Sorry, did you see that message? I'm gonna have to install an update after this class. Okay, so I was saying, suppose a nominal discount rate is 8% and the expected inflation rate is 2%. Determine the present value of a 6-payment annuity of $1,000 real cash flow per year. So this is talking about $1,000 real cash flow. Now those are my 6 years, and I'm told about $1,000 real cash flow beginning. First payment is in 1 year. So remember, For our formula, first payment are 1 year from today, except for the annuity due formula. All right, so those are real cash flows. What does that mean? It means that every year, $1,000 will be received. 1,000 real dollars will be received. It means that you will have the purchasing power of $1,000 today by the end of each year. So if a tablet like an iPad costs $1,000 today, you could buy a tablet at the end of year 1, a tablet at the end of year 2, and at every end of year you could purchase a new tablet, because even though there's inflation and the price of a tablet is going up, your ability or your purchasing power, the amount of money that you have, is capable of purchasing that new laptop. Okay? Now, not to be confused, because sometimes technology improves, makes it more valuable, but this is what I'm trying to say, is that it's, the new laptop today is, and I've noticed this over time, a new laptop or a new iPad, I'm not going to say iPad, because if I go back to the 90s, a new laptop in the 90s cost as much as a new laptop today, although they're completely different technology. So I'll go by that experience. So what the heck does this mean in terms of what we're used to? Nominal dollars are the cash flows I've been talking about so far. Those are referred to as nominal. The new thing I'm talking about are real cash flows. So to be able to purchase an iPad at the end of each year, even though there's 2% inflation, how much actual cash do you have to have available? Let's make an equivalent timeline for nominal dollars. So, in nominal dollars, how much do you need to have if there's 2% inflation? Does anybody know? How much should you have in your bank account? So the idea of this annuity is it's going to, you can think about it as us trying to figure out the value of this annuity, where you're going to receive the purchasing power of $1,000 today at the end of every year. What is that worth? What would you pay for such a product? Well, if the prices are going up 2%, this acts like a growth rate. So this is an application of the growth rate idea. So those cash flows need to grow by 2%. To be able to afford the same thing for $1,000 that you did today. Same thing or the same things that you purchased today for $1,000. And what about in the second year? In the second year, you're going to need even more. In the third year, even more. Everybody's with me? So this is an application of growth rate. It's getting messy. So this stream of cash flows is equivalent to this stream of cash flows. These are real dollars and these are nominal dollars. So the new concept is up here, what I just introduced. This is what we're usually talking about. Indexing for inflation is an example. This is an example of indexing for inflation, is a better way to say it. Questions so far? So doing this, what I've derived for you, or I've real is a concept to relate that I want the same purchasing power in every year as $1,000 has today. That's what a real dollar is. And in nominal terms, you understand it this way. 1,000 real dollars in year one is really $1,020. In year two, it's really $1,040.40. In the third year, and so on. Okay, so it goes up. So what we've determined here is that there's a relationship between cash flows. Cash flows that are nominal at any point in time are equal to real cash flows adjusted for inflation. I'm going to use the symbol for inflation. I can't use I because that's interest, so I'm going to use this symbol for inflation. You may have seen this symbol used for inflation before. So this is what I've just discussed. So what I've done so far in the course this week is introduced, like we've reviewed many concepts you already know, but I've used, to explain them, to discuss them, I've used many applications. And this is the application of inflation. All right, so now what do? We're not done. I just laid out the groundwork for this problem. I want to be able to compute the present value of this annuity. So to calculate the present value of the real cash flows, if I convert them to nominal, I can also calculate the present value but I have to do these, obviously they have to be done different ways to get the same answer, because I should get the same answer. Whether I use real dollars or nominal dollars, in present value terms, those meet, okay? Those will be the same thing. And they are related by this concept here. So, you'll have to discount real dollars with the real rate of interest. And you'll have to discount nominal dollars with the nominal rate of interest. So which one are we ready to do? Well, in this question, I want you to do this. It says with the real dollars, right? Regular annuity with the real amounts. This is a regular annuity because these are the identical cash flows for 6 periods. Right. So here you have an annuity. I want you to use an annuity with the real dollars, but you need the real rate. Where are we going to get the real interest rate from? Does anybody know? Because here I have the nominal rate. I have inflation. I don't have a real rate. Does anybody know how to find it? Yep. So you need the real interest rate with the real dollars. So you have, this is an annuity, right? This is an annuity diagram or timeline. So all you need is the real rate. So what's the relationship between the real rate and the nominal rate? That's the question right now. What is the relationship in a state of inflation between the real and the nominal rate? You should have learned this in economics or in finance, and in finance you should have seen this before. If not, you're going to learn it now. So in economics, you learn about, I'm going to write nominal inflation. So that I'm going to use R for, sorry, not nominal inflation, nominal interest. So this is the nominal interest rate. The nominal interest rate is related to the real interest rate I'm gonna just, for space saving, how are they related? The fact is that they're related by inflation. For every dollar earning the nominal rate, that's made up of the real rate. That's the real cost of borrowing and lending. That's the real cost, the trade-off or opportunity cost of not taking advantage of financial markets, times a growth factor of inflation. Okay? So this is the relationship between nominal and real. Now, you may have seen this as an additive relationship in economics, and that's true. In economics, you learn that the nominal rate is equal to the real rate plus inflation. But this is only an approximation when inflation is small, or less than 1%. Okay, and usually governments have monetary policy to ensure, they enact policy to ensure that it is low, or they work to keep it low. So this is actually a good approximation when it's low. But in fact, this is the relationship. This is known as the Fisher relation. And I'm going to also put that with red because these are the takeaways from this discussion. And I have some notes about this later. Right now I just want to present it like this in an applied way because I want us to practice using the annuity formulas. So, having shown you that, These are the main things you need to know. The relationship between real and nominal cash flows, the relationship between real and nominal rates, and the principle that you discount real dollars with a real rate, discount nominal dollars with the nominal rate. So having said all of that, what is the present value of this annuity using the real dollars and the real rate? You need the real rate. And you'll find that through here. So 1.08 is equal to 1 plus the real rate times 1.02. Solve for the real rate. What do you get? So what we've done till this point is worked with the nominal rate, and that incorporates inflation, the effect of inflation. All right? So the new concept is the real rate. So this would be 1.08 divided by 1.02, if you want to put it like that, minus 1. So what do we want to do with that? Because that's not an easy number to work with, right? We are going to store it. So store it, remembering that you used decimals. And now we need to solve this. We have the real rate, and it's an annuity. So what we're going to write here, I'm going to write the answer. Where am I going to put it? I have so many notes. What I'm going to do is I'm going to move this one down because this is actually the next problem. I have to erase. So I give myself some room. And let's figure this out. The present value then of this annuity of $1,000 for 6 periods at the real rate, I'm just going to write the symbol of interest for 6 years. That's what you want to find out. So you use the annuity keys, 6 into n, and recall 1 times 100 into interest, and then And then and then 1,000 into payment and 0 into FV. So if you compute PV, what do you get? How did I get the real interest rate? It's all here from this formula. What do you get? It should be almost $5,000. What's happening? What are you guys getting? Very good, Miguel. Yes, on hell. That's right. Very good. Here are the steps. 6 into n. This number times 100 into interest. 1,000 into payment. You could also put a negative because, well, whatever. As long as you understand, if you put a positive, you're going to get a negative here, but the interpretation is that's the value. And then 0 into FV. And your answer is about 5,000, 4,935 and 55 cents. OB, I'm not sure what you're doing, but you need this number here in your calculator. You need to store it and then follow the steps here, which correspond to this formula. Well, if you stored it, you need to recall it. So yeah, you're going to recall and multiply it by 100 to put it in here as the interest rate. It has to be as a percentage. This is what we did the last couple of days, annuities. This is just a regular annuity. You need the interest rate because these are called real dollars. We need to use a real rate. I derive the real rate because of this relationship. This relationship, known as the Fisher relationship. And I derive it here, and then I use that, recall, and solve. Anybody else get the right answer? So I just explained what real dollars are by presenting them as nominal dollars that you're used to. So if someone talks about real dollars, you need to know what the inflation rate is, and you need to know at what point in time they're stating the dollars. All these dollars are related back to time 0 because that's what they mean. They mean the equivalent products as $1,000 today could buy. The equivalent value that $1,000 today could buy, whatever year you're in. Okay, so now you should be able to get the same answer using nominal dollars with the nominal rate of interest, which we were given, the 8%. So let's prove that to ourselves. I want to prove to myself that I can get the same answer for this timeline. But notice this timeline is not an annuity, it's a growing annuity. It's not a regular annuity, it's a growing annuity. So I need to use the growing annuity formula for it. No. I'm trying to give myself more space. All right, I'll just do it here. So this is a growing annuity. For the growing annuity, the present value, well, I know what I'll do. I'll just do it on another page. Take this whole thing with me. Whoops. So this is a growing annuity. The present value at time 0, I guess I'll put it over here, is equal to $1,000, the first cash flow, right? The formula for growing annuity is you have to put the first cash flow here. I'll rewrite the growing annuity formula. It should be C1 I minus G 1 minus 1 plus G, the growth in the top, and the discounting in the bottom, all to the power T. So the first cash flow happens to be one period of inflation already transpired. So then it's 2%. Sorry, that's not right. So I is going to be, for us, that will be the nominal rate of interest, and G for us will be pi. So I'm going to adapt this formula for my purposes with growth as the inflation rate and the real rate as the prevailing, the nominal rate as the prevailing rate. So then the nominal rate is 8. The inflation rate is 2. And then 1.02 over 1.08 for 6 years. So try that. You should get the exact same answer that you got in Part A. Exact to the decimal. So to enter this, start with here, right? Just like we did yesterday. So you would take 1.02 divided by 1.08 equals, and then raise it to the power of 6, and then change the sign. Maybe you have to say equals. Equals. And then change the sign and add 1 equals. So that is the bracket, the big bracket here. Then you should simplify this before you continue. This should be 0.06. So then you're going to multiply that result by 1,000, multiply that result by 1.02, and then finally divide by 0.06 and press equals. Should not be negative. Angel, should not be negative. You did something wrong somewhere. But good for trying. Try again. I think maybe you have to say equals here as well. Let's put an equals in there. Yes, Angel, you got, but you got a negative. You shouldn't have a negative. You should not have a negative value, but it's the same answer. It shouldn't be negative. I'm checking, but there's no way. I've done this many times. Your answer should be the same as before. And I round to 2 decimal places when I'm done. How's everybody else? Everyone's so quiet except for Angel and Obed. Miguel, you were off a decimal place before. I don't know why. And Angel, why are you guys off a decimal place? You shouldn't be off a decimal place. You shouldn't be rounding. This should be stored. You shouldn't plug that in, okay? You have to get exactly my decimals or you will lose half a point for getting the wrong decimals. The decimals here are exactly 55 cents, not 56. That was the easy part. The second part's even more challenging. Very good. I have no idea how you got a negative. Okay, so where is everybody else? Miguel, how are you doing? People who have different calculators, as I mentioned, you need to learn how to use them. Okay, good. Yeah. Okay. All right, ready for part 2? Okay, Dariana, how is it going? Have you got this one? Okay, so let's look at part 2. Oops, I went out. Let's look at part 2. So, keeping in mind the 3 things we learned. We learned that we learned the relationship between nominal and real dollars. We learned the relationship between nominal and real rates and inflation. And the principle that you need to discount real dollars with the real discount rate and nominal dollars with the nominal discount rate, and you will get the same value for any kind of valuation at time 0. And we got the same answer doing it this way with the regular annuity and the real amounts as we did with the nominal amounts and the nominal rate. Okay, so now what happens? just one last thing. The point is that there's indexing for inflation here, right? Which in dollars and cash flows in our pocket, these are increasing over time. But what if that's not the case? What if there is no indexing? So here's a situation. Suppose the real discount rate is 5% and the expected inflation rate is 1%. Determine the present value of a 5-payment nominal cash flows of $500 per year, the first payment in 1 year. Find the present value of the annuity using the regular amounts. Using the regular annuity with the nominal amounts. So we need to make a timeline of nominal amounts. Those are the $500. So nominal dollars. I'm going to use black. So we have 1, 2, 3, 4, 5, $500, $500, $500, $500, and $500. So what's the present value using the nominal amount? So we need to have, for nominal amounts, we need the nominal rate. We need the nominal rate. We know that the nominal rate is equal to the real rate adjusted for inflation. The real rate is 5. The inflation rate is 1. So that makes the nominal rate whatever that is. Right, 6.05. Right. Very good. So now we're ready to apply the formula. This is a regular annuity now with, I can just put the number in there, but let me just write the nominal rate. So you can put in 5 to n and 6.05 to the interest, and then you want the PV, so don't put anything there. Payments are 500, and we're not going to use future value. So we compute payment, and you get, not payment, PV. And what do you get? So you get 2,103.32. You can round it now because you're finished. So that's the answer. So there's three concepts floating, right? The relationship between the rates, the relationship between nominal and real, and the principle that you discount nominal dollars with the nominal rate and real dollars with the real rate. And finally, I ask you to show how to get the same result as here with the growing annuity formula and the real amounts. And be careful because the growth rate is not -1%. Now, why am I saying negative? Okay, well, I'm saying 1% because I'm trying to say it's not exactly inflation. It's not that inflation is going to be eroding the value of your money over time, the purchasing power of your money will be diminished by the fact that prices are rising. So in real terms, you can buy less and less and less and less and less. But it's not exactly a growth rate that's negative. It's that there is, you'll see, it's not a multiplicative or additive thing. It is a matter of factors, okay? So these growth factors versus deflation factor. So what am I talking about? So with real dollars, keeping in mind that nominal dollars are related to real dollars by the number of periods of inflation that have transpired. So if I want the real dollars, I have to deflate the nominal cash flows by a factor of 1 plus pi to the power of t. So I want to use that here So the first cash flow, it should be 500 divided by 1.01. I need to make room for myself, so let's do that. Let's make some room. And after 2 years, $500 is 500 divided by 1.01 to the power of 2. It's deflated 2 periods. Okay, and then after 3 periods, and it goes on and on. So this is a growing annuity, but what is it growing at? They're growing negatively for sure. They are not growing. They're not increasing. They're decreasing amounts, but they are in a decreasing in a constant way. They're related by this factor. So the question is, what is the growth factor to put in my growing annuity formula? That's the question. Find the G for the growing annuity formula. It should be a negative, but it's not -1. It's close to -1, but not exactly -1. How would I find it? And then once I put it in the formula, I should get the same answer as I got here. So the first cash flow would be this. The I would be the nominal rate. Sorry, the real rate that we were given as 5%, right? And the G is what we want. So we need the G for here and here. So I'm going to ask you to, well, I guess I should show you because I don't want to spend time on this tomorrow. And then you'll have a chance to look at it tonight. I'll send you the clave. Although my explanation is more in depth than the clave is. So 500 remember that it should be, the timeline should be, for the growing annuity formula, the timeline is C1, then C1 1 plus G, then C1 1 plus G squared, etc., right? So it should look like that's on your formula sheet. So this is my C1, then what is the next C2? It should be should look like this, but then I have another discount or deflation factor here. So it turns out, and then this one as well would be like so what I'm doing is looking here and splitting this up into C1 and then whatever's left. This is the remainder. And similarly here, 500 over 1.01 is C1, and this is the remainder. So it looks like this is 1 plus G. This is the growth factor. So that's how I find my G. Take these together and solve for G. So to solve for G, one plus G is equal to 1 over 1 plus pi. In general, this would be the relationship. So this is the fourth thing I want to tell you about this handout. So notice that when you have inflation, the growth of nominal dollars is going to be a negative when you solve this. Actually, I should write it like -1. This will be a negative. Because this will certainly be less than 1, and then you're minusing a 1, so that'll be a negative. So let's solve it for this problem, and then I will leave it to you to use it for the formula. So G should be 1 over 1.01 minus 1. So that's the rate of growth. Because these cash flows are getting smaller and smaller, this is the rate at which they are steadily getting smaller. So that's what I put into the formula here, and I should get the same answer that I got above. Because because you have to put it in here, oops. Because you have to put it in this formula, you use the decimals, but you should store it. You should store it to keep all the decimal places. And your answer should be the same as this one. So I'm going to leave that for you to try. I will send you the clave now, and I'll send you some additional material to talk about. Let's take a 5-minute break. Okay, I'm back. How did you do with that problem? Anybody get it? Did anybody solve it? So you should get this answer. I just sent you an email with the documents I want to discuss. Plus, I sent you the solution to this. Just, it's neat and tidy. It's cleaner than the ones in the that I just did online. Very good, Kevin. I'm glad. Okay, the others, just work at it and practice. This is just an application, and it'll come up again. I will discuss inflation and discounting again. In particular, unless I mention that you need to work with the real rate, or unless I mention you have real dollars, assume everything is nominal, just like before. Okay, don't get confused by that. Okay, Miguel, you just have to practice later and let me know if you have trouble. Text me if I can help. Or send me your work, your written work. Okay, and then I can have a look and see where you went wrong. So I just sent you some documents. We're going to talk about interest rate conversions. So far, all I've dealt with until just today are not talking about nominal dollars, nominal rates, and pretty basic review of concepts that you have learned. You learned in 3106 and maybe in other courses. Essentially, you're becoming an expert in using a financial calculator and conducting all sorts of financial computations using the same formulas, really. I mean, there are just so many on that sheet that they're all related. It's only really 4 formula that you need to know: the perpetuity, the growing perpetuity, the annuity, the growing annuity, and then how to manipulate them on the timeline to get what you need, to apply them to a variety of problems, variety of applications. So we're going to take a step back before we re-enter into solving more complex, more realistic problems. We have to step back and talk about interest rates. So beyond the real and nominal concept, we have to talk about the effective and stated rates. So here we have a very practical example. This was my credit card statement. Now if you have a credit card, you also have some part of the credit card statement that tells you this information in some form or another. Which rate is the effective rate that I actually pay on my credit card? Is it this one or is it this one? Is it the APR or is it the daily interest? Are they the same? And if they're not the same, are they related? If they are not related, what are they? So which rate do I actually pay on my credit card if I have a balance? I don't have a balance here. I usually do not have a balance on my credit card. I pay off the balance and I use the credit card to improve my credit score and otherwise I stretch out my spending so I don't have a balance. It helps me. I'm good at taking advantage of the opportunities afforded to me, and I don't abuse them. It's really easy, for me to say, but I have had times in my life where I got stuck, fell between the cracks, and had balance on my account. But I work really hard to keep a zero balance credit card. So anyway, after saying that, tell me, which is the rate that I pay on this credit card? Okay, Angel has stuck his neck out and said it's the APR. What does anybody else say? What do I actually pay on my credit card? Right, so I have no interest, right? But if I have a balance, I have to pay, right? What would be, if I had a balance, what would I have to pay on my credit card? Do I pay the APR or do I pay the daily interest? So it looks like, thank you, Danielle. You think the APR? Anybody else? Can everybody try and answer? Just take a stab at it. Just take a guess. Go for it. Okay, well, you're asking, Angel, you're asking me to answer a question? So they are related, yes. They are related. So which one do I actually pay in the period that it's stated? I think that's a better way to describe. So APR stands for annual periodic rate. Do I pay this annually? That's the question. This one is called the daily rate. Do I pay this daily? On a balance, this is actually what I pay. All right, I pay on credit cards, you are charged on outstanding balance, you are charged daily. And this is the daily rate you're charged. Because small, it looks small, but it can add up. So I give this a special name. Just like APR is a special name, I'm going to call this the daily rate, right? This is in particular, it's the effective daily rate. In other words, it's the rate per day compounded daily. That's right. Daviana, you are right in the second case. In the first, no. I'll explain the difference, okay? This is a really important concept. So the daily interest is if you continue to have a balance that you do not pay. So every day you get charged this rate. Now, let's say you don't pay the balance for a year. If you don't pay the balance for a year, tell me for every dollar of the outstanding balance how much interest accrues. Can you figure that out? So what is the effective annual interest paid per dollar outstanding so if you left the balance there, so this is the decimal and this is the, this is the percentage, this is the decimal version. You can write it either way. I wrote it like that because I want to use this number. So we learned the basic time value of money formula. What I'm asking you now, if this is $1, and we have the effective daily rate, let's say it's called I. After 365 days, what will it be? So this is for each dollar, because I want it to be expressed for each dollar. So that's going to be 1.00050,411 to the 365. Very good. So this is it's not a percentage. Oh, you didn't put a percentage. You put 1.201960, whatever. So what does that mean? The $1 is the principal amount. This is the dollar here. This is the rate. So this is the effective annual rate. You always have to take off the 1. So the effective annual rate is equal to 20.196%. I'll leave it or I'll round it. Let me round it to 20.2%. So this is what you really pay. This is what you pay per day. I'm going to give that a name too. I'm going to call that the effective periodic rate per day. And I'm going to relate everything to portions of a year. So from this is what I've got so far. I know that the daily rate is 0.05411, and if I have an outstanding balance after a year, this will accrue 20.2% interest. That's the equivalent effective rate. I keep saying effective because that's actually what you pay over that period. Okay, so this is the equivalent effective rate in annual terms, where this is the daily effective rate. So just as a summary, what is the relationship between these two symbols? What do you think? Is that good? Well, first of all, it's much higher. I mean, not much. Well, it's almost 2% higher than the APR. So the APR can be deceiving because it doesn't reflect the actual interest that you pay. So before I get to talking about what this is and how it relates, what is the relationship between these two? Let's write that out. The relationship between these two is that an annual, for every dollar, the annual effective rate is equal to the annual daily rate, the effective daily rate, not annual, the effective daily rate compounded for 365 days. That is the relationship between those two numbers. So I've moved from here. This helped me calculate it, but this is really what I want, is to understand these symbols. So 365 factors of accumulation make one factor of the annual rate. This is the relationship between those two, and you effectively pay more than 18.4%. Okay, so as a side point, what's a good credit card rate? When I moved from Canada to Puerto Rico, the rates, well, in general, interest rates are lower right now, okay? Because of economic circumstances since the last 10 years. Since the global financial crisis, interest rates have been record low. However, at the same time, it's harder to get credit because of, it can be harder to get credit for some people who have a bad credit history. So anyway, there's so many things to think about. So depending on who you are, you can get different kinds of rates offered to you. In the United States, I, as a new resident, wasn't able to get a credit card, but as soon as I was able to, after 5 years of living here, it's a long time, the rates in the United States are much better than the Canadian rates. So rates in the United States, you can get 15, 16, 17%. The worst are department store cards in like Macy's and JCPenney. Those are high, 20, 25% rates. I would consider those high. So yeah, something between 15 and 20. But really, you don't want to be subject to those rates, right? You want to pay off your balance and use your credit card in a smart way. I can tell you guys about some tricks, maybe as an incentive, about how I use credit cards to actually get money. I leverage my credit cards. All right, so let's continue. All right, so what is this now? So what in the world is this, and what allows them to put this on my credit card statement? Can someone tell me? What is the relationship between these? Try and figure it out. Maybe someone has. Okay, so Kevin did it already. So then this is the relationship between these two. EPR, this one, times 365 gives you this. Well, what did we learn about that? So let me see, I'm going to write that out too. I'm going to write that as, I'm going to give this one a name. So this one, let's see, this one I gave a name. I called this EPR 1 over 365 because I say it's a fraction of a year. All those subscripts are in fractions of a year. Then this one, this one I'm going to call, I'm going to give it a different symbol. This is called R 1 over 365. I'm going to make this bigger. And the relationship between them is that this was equal to 365 times the daily effective rate. When I multiply an interest rate, that gives me the simple interest. You remember that? We talked about simple interest and compound interest. This just gives me the simple interest. That's all this is. And it's fair. I mean, I can use the figure, I can use the number if I know what it is, if I know what it represents or how many periods of simple interest have been accumulated or multiplied. I can use it to get this one. Why do I want this one? My goal is to have the effective rate because I want to use it in my formula. You can only use the effective rate in our formulas on our formula sheet. Okay? You can use this one, the simple interest to get the effective one. How can I do that? Well, this is equal to R1 365 divided by 365. So either if you have the daily rate, you can multiply by 365 to get the simple interest, or if you have the stated simple interest rate, you can divide by 365 to get the effective rate. So either of those are related. Exactly, Angel. They charge you as compound. So this is very deceitful, in my opinion. But they assume you know this. They assume consumers know this. There's lots of assumptions in the finance industry that they're able to make. And a huge one is that people are financially literate. So this number is useful, but you need to transform it into an effective rate to use it. Okay? It's only useful in that it gets you to here. But they gave me both, so I didn't really need this. But this is what they're trying to tell you, that it's an 18.4% rate. And if you used a rule and said, I don't want to use any credit cards with a rate more than 20%, this is not the number you need to look at. You need to compound it for 365 periods, this daily effective rate, to see what the real rate is, the real effective annual rate. So why do companies get to do this? Well, they all agree to state their APRs, and so when consumers are shopping around, they compare credit cards by their APR. Since credit cards, I don't know anyone that don't do it this way, credit cards have daily interest charged on outstanding balance. You could, from credit card to credit card, compare the APR. And say, well, this one is better than a credit card that has a 25% APR, but it's not giving you the effective rate that you're actually paying. All right? So that is, I'm going to summarize that information down here. So what did I say? I said that you can get the effective periodic rate from this, what's called the stated annual rate, or sorry, it's called the stated daily rate. When I say stated, it's always in reference to the year. And that's the relationship. You want to convert it to get the effective daily rate. So there's some terminology around here. So this is the effective annual rate. This is the effective daily rate. And what do we call this one? R1 over 365. So again, the point is that you pay interest on interest. You pay compound interest on outstanding balance, and that's not captured in the simple interest rate. Now, maybe 2% doesn't look like a lot to you, but it's definitely a lot from the perspective of the financial institution that operates in trillions of dollars. An extra 2% without the public knowing or realizing it is a lot of a discrepancy. So what is R1? Let's put a name. So let me recap here. I said, let's put some, I don't know if this is more confusing, but okay, the effective daily rate is the rate per day compounded daily. And let's say the effective annual rate is equal to the rate per year compounded annually. And finally, we're going to give a name to that other simple interest rate. I'm going to refer to it as the stated daily rate. Which is the rate per year. So it's stated over the year, but it compounds daily. So how do you know you have a stated rate? You know you have a stated rate when it says per year, but this says a different thing. When those differ, you know it's a simple interest rate. Notice here, this says per day compounded daily. That's how you know it's effective. This one says per year compounded annually. Those are the same, so that's how you know it's effective. When they're different, per year daily, that is a stated simple interest rate. Okay, so question. So you've probably seen something like this before. We're going to spend tomorrow on this. And I'm going to give you, I'm going to do right now, I'm going to give you, well, not right now, because we're going to talk about this some more, but I'm going to send you a bunch of exercises that you can start trying. So tomorrow we can review them together in advance of the test on the weekend. So did I send you the other document? Let's see. Okay, so you can open 2.2. So, if you want, you can take a screenshot of that, if that helps. So this is an example of equivalent effective rates. This is going from one effective rate to the other. And this is an example of going from a simple interest to effective rate. And the main point is that our formulas use effective rates. So we need to have the effective rate. So if you have the wrong one, you need to get the right one. If you have another effective rate, you can make a conversion between effective rates. If you have a simple interest rate, you need to make a conversion to the appropriate effective rate. All right, so I gave you another document that just goes over this that you should read. And you can just read this through. I give some examples. So R with a subscript 1365, that's just the symbol that means the annual rate compounded daily, or the stated daily rate. And I say, as an example, credit cards are like that. How about R112? This is a monthly stated rate. Okay, mortgage rates are monthly stated rates, and you need to convert them to know what you pay monthly on a mortgage, or interest monthly on a mortgage. Quarterly rates, stated quarterly rate written R1 quarter, often it is the case when dividends are paid to stockholders, they're paid quarterly. So that will come up for that scenario. And then the example of stated semi-annual rate R1 half, that's the case of coupons on bonds are actually paid semi-annually. Okay, so you would also have that the coupon rates are stated semi-annual and the yield to maturity on bonds are stated semi-annual. So they all have to be adjusted before we use our formula. And then I just go through the most important, well, you know, I can make this very complex, but I don't. I just focus on these 4 rates. I talk about a few others in the exercises, but I focus on these 4 mostly. The daily effective rate, the monthly effective rate, the quarterly effective rate, and the effective semi-annual rate. This one for credit cards, this one's for mortgage, this one's for stock dividend payments, and this is for bond coupon payments. And then I have some other examples too. And I show the formulas. So all right. Okay, so you have that. Now I'm going to send you some more. Give me a moment. Okay, I just sent you some more documents. (2.3) and 2.4. I'm going to do my best to keep everything numbered so we can reference them very easily. Okay, so I gave you this one that summarizes the formula that you're going to use. This is for converting between effective and stated rates, and this one is for converting between effective and effective rates. Now, just like I can relate 1 year effective annual rate to 365 days of the effective daily rate, I could also say that's the same as 12 months, 4 quarters, and 2 semi-annual periods. These are all equivalent effective rates, and that's going to be useful. So I'm just going to leave that with you. That's like, your add-on formula sheet. And I use as examples here the credit card example again. But what I want to do is work on these exercises, and I'm going to send you some more after class. We only have 15 minutes, but let's see what we can do here. Okay, let's see. Let's just try this problem together. Yeah, because there's notes in here, so let's just work on this together. I'll just take this portion to answer the question. And start on a clean slate. So here we go. Consider a bond paying semi-annual coupons at an annual rate of 12%. Okay, so what you need to always remember from now on, from here on out, is the first question you have to ask yourself. I think I'll say, what is the timing of payments? When are the payments? Or I'll just say, when are the payments? When are the payments? Now, if there are no payments, you don't have to ask yourself that question. But if there are payments in a problem, you ask yourself, when are the payments? Okay. All right. So when are the payments? In this problem, semi-annual coupons. All right. So I'm going to highlight that. I'm going to highlight semi-annual at an annual rate of 12%. So that is already telling me something is up, because it says semi-annual coupons, but this is the annual rate. So this is a statement of simple interest that needs to be converted. In other words, this is AR 1/2. It's stated over the year but the payments are semi-annual. So we need to convert that one. With a face value of 1,000 maturing in 25 years, the bond's market value is this. So we have the price, we have the face value. We have the face value here. We have the price here. And we have T here. And you want to find the yield to maturity. Yield to maturity, notice they want the bond rate per year compounded, I'll do it in highlighter again, per year compounded semi-annually, also a stated rate. Now there's two R1/2s. One is, this is the coupon rate. This is the yield to maturity. Obviously I have to use different symbols, right? So what I'm going to do is I'm just going to write like. This is like R1/2. Okay, so it's a stated rate. All right, so payments are semi-annual. So you need to convert all variables to semi-annual periods. So let's write out the formula that we have for the bond and then talk about what we have to put in there. So for the bond formula, we have to use this, right? If there's the annuity portion, and then the face value. So there's the two parts. So we need to do all of this now in semi-annual periods. So let's start with the payment. This is the payment, right? The coupons. You're told that the coupons have an annual rate of 12%. So your coupon rate, they tell you, is 12%, but you know that we need to divide that by 2 to get the semi-annual rate. So we have to take this and divide by 2 before we multiply it by 1,000. So that's going to be 0.06 times 1,000, which is $60. So that's what goes in here. Now, the yield is what we want, so I don't actually have to fill that one in. What else do I need? I have the face value of 1,000, and I just need time. So if it's 25 years, that means 50 semi-annual periods. So that's going to be 50. So let's put that together. Let's put it all together. And we have PV0, oh no, sorry, we know PV0. We know this is 1,057.98 equals $60. I want that rate. And what I'm going to do about that to remind myself is that the formula only uses effective rates. And since payments are semi-annual, then the effective semi-annual rate is the one that I have to use. So this is the sort of thing you have to write on your test. Okay? So that's all you have to do. Now, calculator. We put, not 25, sorry, it should be 50. I put the wrong thing. Typo alert. I said 50, but I wrote 25. So, putting this into my calculator, 50 into n. I want to find interest, so I'm not going to put that in. Then PV is 105798, which is paid now, so put a negative in. And then receive the payment of 60 and receive the face value of 1,000. And ask for compute I. What do you get? So all this preparation and trying to understand the problem, it's very simple in the end.